Sensing Strategies Incorporated is a small business in central New Jersey that is designing new sensors for Navy directed energy test and evaluation applications. These sensors will provide a new capability, giving Navy testers the ability to receive live radiometric feedback from downrange measurements of propagated signals. The sensors are designed to work over very broad spectral ranges, which will enable their use with a variety of laser types as well as broadband sources. The sensors will enable faster and more reliable testing and improve operator training by providing live feedback, which will accelerate the acceptance of lasers for a variety of defense applications. Incorporated in 2000, SSI carries out remote sensing research and development for defense customers and produces novel electro optic sensors for remote sensing applications. Some of SSI's sensors have been used for threat warning and countermeasure queuing applications, and others have been used for calibrated radiometric characterization of lasers and broadband sources. Our sensors are routinely used in field applications to characterize atmospheric transmission, measure propagated laser amplitude distribution, and quantify target reflection signals and off axis scatter by atmospheric aerosols. The company founders have extensive experience in using models to predict radiometric signatures and sensor performance. We use rapid prototyping to prove novel sensor concepts in the lab and field. We have built final production sensors for land, sea, airborne, and spaceborne applications. SSI also excels at designing instruments that can make real time, quantitative measurements of optical signatures and implementing the algorithms in fast computing architectures for providing feedback to operators. This program will make use of all of these skills to provide a new capability to Navy directed energy developers, testers, and operators. The problem posed by the Navy is that new sensors are needed to provide downrange measurements of propagated sources over a wide spectral range. The whole spectral range needs to be measured simultaneously, given the temporal dynamics related to signals passing through the atmosphere. Sources can include lasers and broadband sources, which could be used for atmospheric transmission characterization and gas species detection. The sensors need to have wide field of view and work in day and night conditions. The sensors must also have a wide instantaneous dynamic range, given the amplitude variability of propagated laser signals. The Navy's goal is not only to have sensors to make the radiometric measurements, but to have the sensors report the spectral irradiance and fluence data in real time to the source operator over a radio link. This capability is one of the innovations being developed along with the broad spectral coverage required by the Navy. By having live feedback about the signals downrange, the testing and training will be much more efficient than is possible currently. For example, operators could make adjustments to laser system parameters and see in real time the effects on the power level delivered to the targets. There are multiple motivations to provide live feedback from downrange sensors during propagation testing. The sensors support developmental testing by providing immediate feedback to operators when adjusting laser system parameters during propagation testing. They measure energy on target for system acceptance tests. And finally, they provide feedback to laser operators undergoing training and operational tests so they understand the laser system effects on target. Navy and other DoD organizations would benefit by using sensors with these capabilities. Both the Dahlgren and Crane divisions of Naval Surface Warfare Center engage in directed energy source testing and have expressed an interest in live feedback sensors. Extending this capability to supporting training for laser systems deployed on Navy ships would be another valuable added capability. Experiments were carried out with different types of sensor breadboards to explore the broad spectral coverage and spectral resolution requirements of this program. The process identified the most promising path, and the sensor designs are being assembled for laboratory testing. Once the concepts are proven, field deployable sensors will be built for field test use. Static tests are planned for the initial test phase, so the sensors will be tripod mounted for ease of pointing. SSI will write software to convert the measured data to calibrated irradiance units for transmission to a terminal located near the laser operator. SSI uses broadband and monochromatic calibration references traceable to the National Institute of Standards and Technology. The nature of the experiments supported will vary according to user needs. Some developmental tests can be supported, for example, if an operator wanted to experiment with adaptive optics under turbulent conditions. Alternatively, an operator may need to verify the irradiance on target for acceptance testing of a laser system. The sensors delivered will be flexible for providing real time feedback to laser operators, whatever their mission is. A subassembly is being developed for the broadband measurement sensor to implement the techniques proven in initial breadboard testing. SSI is testing the subassembly with laboratory sources in Pennington, New Jersey, in preparation for initial testing of the sensor at government laboratories. The goal is to produce seamless spectra for the sources under test. The sensor will measure multiple laser lines at the same time and also quantify broadband sources. Measurements of broadband sources can be made to characterize an unknown source or study atmospheric effects such as transmission. The possibility of detecting gas species through the absorption features in the transmission spectra are being investigated. A successful transition for this Phase 2 program is that NSWC Crane Division will be able to operate the new sensor on their own to collect the radiometric data. The Navy's goal is to accelerate testing of novel laser sources by having unique measurement capabilities that help reduce the time required for test preparation, execution, and analysis. With the broad spectral coverage of the sensor being developed, it could transition from one type of test to another with no modifications or new calibrations required. In addition to being able to transition between tests, the live feedback provides concrete evidence that the desired measurements are being accomplished. Similarly, the test director and laser operator will have access to quantitative results during the test, which means more variations and parametric excursions can be carried out efficiently without waiting for weeks of analysis to determine if the test objectives were met. A successful transition of the sensors will be when NSWC Crane Division is able to autonomously carry out tests with the new sensor. For their purposes, the sensor will have roles in laboratory and field applications. Radio links will be arranged for the Navy test ranges so the real time data can be disseminated to the laser operators during the test. It is anticipated that additional sensors will be ordered as more test ranges become aware of the capability to carry out this kind of testing. These purchases of the sensor can be made through a Phase 3 contract or through direct order from SSI. A second kind of transition will require modifying the design to make it compatible with airborne platforms. A second Phase 2 or Phase 2.5 contract could be used for this new application. In this role, it is still assumed the sensors are being used for developmental and acceptance testing by the labs such as NSWC. As the laser technologies mature, the need will grow to have this capability for dynamic tests on domestic test ranges. The third type of transition will require a Navy sponsor to adapt the sensors for use in training and testing for deployed laser systems. In this application, the Navy ship could have its own unmanned airborne vehicles for flying sensors to serve as targets with live feedback to give the laser operator concrete evidence of the effects of their laser weapon. It is believed that this kind of tangible feedback on laser weapon effects will accelerate the adoption of the new weapon technology. Other directed energy applications will emerge as the sensors and their measurement results are introduced to the test and evaluation community. However, applications not related to directed energy propagation are likely as well. For example, signature measurements of broadband sources could be carried out such on flares or other broadband missile countermeasures. The same sensor could be used to characterize atmospheric transmission if used in conjunction with a known broadband optical source. SSI is exploring the sensor's utility for other atmospheric characterization applications such as pollution detection as well. SSI is able to fabricate and deliver the sensor for use by NSWC. No partnerships are needed for this level of transition or for building repeat units of similar sensors for other DoD organizations. Similarly, SSI can modify the sensors designs to adapt them to unmanned aerial vehicles. However, partnerships will become more important for transitions using the technology to support testing of lasers on Navy ships. For example, identifying how to get the radio linked data to a laser operator through the ship's computer network will require a transition partner familiar with that system. SSI is capable of helping organizations quickly assess new measurement applications and develop novel prototype instruments. The real time processing capability provided in our sensors makes them suitable for use in warning and self protection applications. SSI's sensors can cue countermeasures, assess atmospheric effects on propagated beams, measure laser scatter out of the beam, and determine if there are hazards associated with target reflections of the beam. We can quickly adapt our dissemination methods to user requirements. SSI encourages military and non DoD laser developers and users to approach us about new applications for which a measurement capability does not currently exist. Thank you for your time.